Hello, welcome to lesson 5 on the topic permutation combination. If you remember, we have been discussing the typical applications, the popular applications of combination. We have already discussed 3 such applications. Now let me tell you the 4th one. This is something very interesting. It is beautiful, asked very often. Let me share this with you. Suppose we have a grid which is a 4 by 4 grid. Alright. So as you can see, we have a 4 by 4 grid. Correct? Now what is the question that we are trying to answer? We are trying to answer 2 questions. The first is, what is the number of rectangles? And the second is, what is the number of squares? Right? Now, some of us would be wondering, why are we talking about this suddenly in the middle of the application of combination? Now, let us see, this is where the concept and its understanding will come into play. The number of rectangles, please appreciate, dear students, the number of rectangles is something which is not to be counted. If you start to count them, it is going to be very time-taking and extremely cumbersome. How do we get to the number of rectangles? Very easy. Please appreciate, in order to make a rectangle, I need 2 vertical lines. Which 2 vertical lines? Any 2 vertical lines which are parallel. And along with this, I need 2 horizontal lines. So 2 vertical lines and, very important, and 2 horizontal lines. Will this form a rectangle? Absolutely. What if it is a square? Every square automatically is also a rectangle, right? So 2 vertical lines and 2 horizontal lines. In a 4 by 4 grid, we have 5 vertical lines. How many lines do we have? So we have 1, 2, 3, 4 and 5. The number of lines will always be 1 more than the size of the grid. Always. Okay. So we have 5 vertical lines and we have 5 horizontal lines. What do I want to make a rectangle? I want 2 vertical lines and 2 horizontal lines. So I need to select any 2 vertical lines out of 5. What will we call it as? 5C2. Then and so multiplication, and any 2 horizontal lines? Absolutely, any 2 horizontal lines. How many ways? 5C2. So what is 5C2? 5C2 is 5 into 4 upon 1 into 2 into 5 into 4 upon 1 into 2. So 10 into 10. There are 100 rectangles that you can count on this grid. Okay. Now, please appreciate, for many of us, we do not know that the number of rectangles is nothing but an application of combination. So I hope you all are clear about this, right? So what is the number of rectangles? We need 2 vertical lines and we need 2 horizontal lines. So select any 2 out of 5, select any 2 horizontal lines out of 5 and you have a rectangle. Correct? Okay. Now, some of us would be thinking, is the number of squares an application of permutation combination? The answer is no. Right? Why are we talking about the number of squares here? Because usually these 2 questions are thought of and discussed at the same time. That is why we are talking about the number of squares. Right? Now please understand, how do we find out the number of squares in a grid like this? The number of squares is nothing but the summation of all the squares from 1 square to 4 square in this case. Okay, it is nothing but the summation of all the squares from 1 square to 4 square. Give me a minute to explain the logic to you. Right? We are not saying that this is a formula which you have to directly understand. There is an absolute logic behind this. Let me tell you. Okay. Now, let me start from here. What is this 4 square? This 4 square actually represents the size of the number of squares which are 1 into 1. So how many squares which are 1 by 1? There are 16 squares. That is what is represented by 4 square. What is 3 square representing? 3 square is representing all those squares which are 2 by 2 in size. Can I show it on the board? Absolutely, I'll try. This is 1, this is 2, this is 3, then we have 4, and then 5, and then 6, and then 7, and then 8, and then 9. So what is the number of 2 by 2 squares? 3 square, 9. What is this 2 square representing? This 2 square is representing all those squares which are 3 by 3 in size. Okay. And what does this 1 square represent? This 1 square represent all these squares which are 4 by 4. There is only 1 square which is 4 by 4, isn't it? And that is what is represented by 1 square. So what is the number of squares? The number of squares is 1 square plus 2 square plus 3 square plus 4 square. If we come to calculate it, it is 1 plus 4 plus 9 plus 16, 16 and 20, and the number of squares on this grid is 30. Now both these questions are very popular part of many papers. Alright. Sometimes, you know, instead of the grid, the examiner would be talking about a chessboard. So how will the question translate into? What is the number of rectangles that you can count on a chessboard? What is the number of squares that you can count on a chessboard? Alright. Another very important and interesting application of combination. Right. So students, I think by now all of us have a fair idea. Allow me to take out this part. By now all of us have a fair idea of what combination is, the concept of combination, how the questions have to be approached, and some typical applications, some popular applications, examples of combination. Before I take you to permutation, there are two examples that I would like to discuss. To tell you two specific things, and then maybe we can move on to permutation. So listen to these two examples very carefully. The first one is like this. A team of 4 people is to be selected. A team of 4 people is to be selected out of 7 men, or rather let me increase this. A team of 6 people is to be selected out of 7 men and 5 women. Okay. The question is, in how many ways can we do this, right? A team of 6 people is to be selected out of 7 men and 6 women, having at least 3 men. Having at least 3 men. Okay. So now what I am trying to tell you is that a question like this can be approached in 2 ways. How? The first way is, we can say that the team can have 3 men and 3 women, or the team can have 4 men and 2 women, or the team can have 5 men and 1 woman, or the team can have all 6 men. Okay, it can have 3 men and 3 women, or 4 men and 2 women, or 5 men and 1 woman, or all 6 men. Now sometimes an easier way to approach such problems is to look at and solve the complement, right? So what if the team does not have at least 3 men? So then what will be the case? It will have 0 men, and can it have all 5 women? No. So this case is anyway ruled out. this case is ruled out. Okay, so we are talking about 1 man and 5 women, 1 man and 5 women, or 2 men and 4 women. What are we trying to do? We are trying to solve the complement. And then what we will do? We will subtract this from the total. Correct? I hope you are understanding. So instead of trying to solve this, and you would appreciate, suppose I change it to at least 1 man or at least 2 men. Now this approach will become easier for me. Alright. So what we are saying, 1 man and 5 women or 2 men and 4 women, this has to be subtracted out of the total. So what is the total number of ways? The total number of ways where we do not have any condition is 12C6. Right? What is the number of ways for this condition? So we are talking about 1 man and 5 women. So 7C1 and 5C5, or 2 men, that is 7C2 and 5C4. So this total, this subtracted out of the total. And what is the total? The total will be 12C6. So is the complement a better approach? Absolutely, in this case, and that is what you have to realize as a student. Alright, so we have 12C6 minus 7C1 into 5C5, or 7C2 into 5C4. This is going to be my final answer. What will be the value? I leave it for all of you to solve. Not very difficult. You can very easily solve this and find out the particular answer. But what is the learning? Very important. The learning is in permutation combination and subsequently in probability, an easier way to approach the question, an easier way to approach some of the questions will be to attempt the complement of what has been asked in order to make it easier and less time consuming. Thank you.